Alright, so I think we're up now. I hope my background noise isn't that bad. Even when I'm not talking, my little mic thing is kind of pinging a lot. So I guess let me know. I'll take that out. I'll give it a few minutes for more people to connect before kind of diving in. I think I'll mostly kind of touch on Lab 6 and answer any questions. And then we'll obviously go over Lab 6 Friday, and then I'm sure we'll have some time. Then I'll kind of do more of a discussion on the homework, and then Sunday cover the homework in like a high level sense. But if you haven't checked, the lab, which I pulled up here, is on linked lists, which is a topic in the OLI module for the week, and the homework is on the, it's like a guess the word game, kind of akin, very similar to the game Hangman. Yeah, so that's it. It's way less scaffolded than the tic-tac-toe game that we had for the previous week, but it's kind of in the same vein of this is a pretty simple game that most people know, which makes it a good topic. And its logic kind of naturally breaks down into different steps that lend themselves to helper functions. So then the idea is you kind of program the game, from the bottom up, filling all the logic and ideally kind of putting different parts of it into these helper functions that are then called from this kind of main function like we did for tic-tac-toe. So then it all comes together and you can call this function once, start, and then play the game. Then it kind of carries out all these different commands. And so I kind of explained some of the logic of that in the actual file itself. I even kind of did like a high level breakdown in case you're new to the game or needed help finding starting points, because I know sometimes that stuff can be overwhelming. So if you kind of break it down into like, okay, well I know I need to check for the one condition, I know I need to get the user's input, and then like I need to kind of print the state of the board and how many letters are guessed. If you kind of chunk it like that and then write the code for that, you'll find that it kind of naturally fits into these functions, or you can combine them to into one kind of function that you can then call from this main start function. It makes it a little less daunting if you do it kind of piece by piece. So I'll give it probably 2 more minutes or 1 more, and then kind of talk about Lab 6 rather. Making sure my internet's not weird. I can never really tell what these like YouTube live messages really mean. Alright, it's basically 5 after. I'm just going to go in. So if you've looked at the OLI module yet, there's it's kind of on data structures, right? As I talked last video, it's kind of like language agnostic, so it doesn't really have like Python code, but the logic still stands, and there's kind of pseudo code written in there that kind of naturally translates to Python. As people always say, kind of Python is pseudocode. Just the way it writes compared to other languages, which makes it a great intro language. And I mean, it's still like super widely used. But so of the 2 main takeaways that I think I mentioned as well, kind of this notion of 2D arrays is pretty big, as you'll see here, kind of on page 50. So that's one, but then we've been working with like lists, which are basically arrays, this kind of whole time, and so the 2D aspect of them, I think, is maybe something that would not need as much focusing on, but linked list kind of is a whole new data structure, and kind of like the second one we basically worked with, if we kind of rope lists and arrays into the same thing. So I think it makes for a really good homework. Or lab. And I'll show you the file in a second if you haven't looked at it either. But it kind of does introduce these other two concepts that are kind of needed to make this linked list. But the core aspect of the homework or the lab is getting experience kind of making this data structure, right, of linked lists, which will kind of be a first for us. And in particular, I think page 52 is super helpful because in the lab, you'll be doing search and size, so getting the size of a linked list and searching for an item in the linked list, which to do so, you'll need to traverse the linked list. And then this even has kind of searching for an element, and these videos are really short, right, like 40 seconds, and it kind of breaks down the logic of it, so then we just need to translate this to Python code. But I think the challenging part, and part of why I wanted this as a lab, is because if you look at the file, I have a bunch of kind of starter code that you don't really need to mess with. Up here, I guess in particular this one, this class node with all these kind of functions here that have some comments. And so all of these kind of functions aren't really new. This notion of a class and kind of object-oriented programming totally is. So I wanted to have this in the file, even though I know that might be challenging, because I wanted to walk through it Friday, and I thought labs were a great opportunity to do that. And the actual kind of lab code that you'll use here, like to do size and search, just basically contains like a loop and like maybe an if statement. But you will need to call these kind of functions that the objects have. So I'll start walking through that right now, in case I'm making things worse. And also on the lab, I provided these two links to kind of objects and classes in Python. And then kind of very similar documentation. It just has a different example, and it's kind of more conversational because it's like a Medium post. I think I like them both pretty equally. I think there's two of the best resources out there for it. I mean, like W3 Schools, which I always... Whoop. My spelling wrong? I feel like I always do that. There we go. So we have things like that, right? So basically this is like rounding up. If you have, any kind of fraction or decimal right here. So we're importing this math module, and you can think of math, same with random, right? When we do things like import random, is that it? Yeah. 5 to 10. Right, so we import these modules, which you can also think of as libraries. And then we're able to kind of use them, right, random, and then call these different functions that they contain. So you can think of it as an object. So for the rest of this kind of video, when I say like object, I basically mean things like math and random, or ones that we create, such as node right here. So right, we have this thing that we import, and then in here, this is basically like an import. So when we import math, it gives us the ability to call this math object, or like this keyword, right? And then do dot, and then we can call all these different kind of methods on it. So ceiling, I think floor is one, right? So this math kind of object, this math word, has all these functions on it that we can call, and we've been doing that. We did randint, we used ceiling before. Optionally, you could use some other random and math stuff. But basically, it has these functions for this item, and you can find these, Python, I think you can, functions. Right, so these are all the things we can call on it. But we enable that through doing an import statement. make sure we're still good. So this class.code is saying, hey, we have this, we're trying to make like another object thing, right? We want a class node that's very similar to math. So, you know, we kind of are saying, hey, we want to be able to make objects of this kind of type, and we want to be able to call these different functions on it. So you could kind of, you can't do that because it's a keyword already, but you can think that we're doing like math, and then, you know, def like ceiling, and then, you know, whatever, somehow round it up, right? And then we would be able to call like math.ceil. But we already have math, and so we're not doing that, but we're doing this for node. So, there we go. Let's actually run this. So, node equals node. It'll give me autocomplete here. Okay, so now I have node, and I can call these different functions on it, very similar to how I can do math, you know, ceil and floor and whatever else it can do. You see, it's just like this keyword, right? And so this is known as like an object. Oh, look, idle even autocompletes for me. It's kind of nice. So classes, I think actually one of these has a really good. And you technically don't need to know all of this to do the lab. I just think it's like super key kind of thing. One of these had like a pretty good quote, I feel like. Yeah, a class is like a blueprint and a model for its objects. So you have this thing called a class, and it does kind of act as like the blueprint or like the instructions of what the object can be, right? So this is like an object, node is called like an object, math you can treat as like an object, random you can treat as an object. But for it to know like what I can do, like what functions I can call on, like get data, get next, set data, which are all like right here, that is where like the class kind of comes in and tells it, hey, these are the functions that are made available to objects of this class. And I think this medium one has pretty nice, I mean, I wouldn't go like too into like the theory part, but the kind of examples they walk through are great. So like a vehicle, like you make a class, we're going to call it vehicle. And then you have this variable, you're making car, and you assign it to this class right here, and now car becomes an object of class vehicle, right? So car is just a variable we made. We're setting it to equal to this vehicle in a way that makes it like an object. And I mean, I would just honestly go through this Medium article, it kind of breaks it down. But when we do that, so we have, you know, class vehicle, and now car can basically use any functions that are contained in this class. And that's similar to this. So if I make this node object, you know, by doing this, then I can call get data, get next, set data, and set next on it. And another thing, I bet it doesn't go into, yeah, it's this whole self thing. So hopefully that helps a tiny bit. It's probably still unclear. I think if you go through these two, it's honestly like 10 minutes each. They're not bad reads. They should clarify it. But another thing is you might be saying, okay, well, hey, when you did like, you know, node, how come it says like in the data here? And so this, which I do think they both cover, is this like, thing called like a constructor or like an initial function for it. And it's always kind of this, and it has this weird notation, right? And that's saying, you know, so in the vehicle example, they just did that. They opened the parentheses and then they closed them. As we can see, yeah, right here. And that's because if you look up at class, like there's no kind of constructor, like initialization function. So it doesn't take anything in. But in Node, we do have one. Right, we have this init data. And then you'll see self everywhere, like for get next and for get data. And we do get data, you'll see it kind of just closes it. Self is just kind of weird class kind of notation. So like all functions in a class basically will take in self, but you can just like ignore that. So you really want to just count everything past self. So if we just see this, even though it does have a parameter, just pretend it doesn't, like treat it as it doesn't have one, because that's just like a thing for classes and objects, which one of these I don't think goes into. I think this one does. But I think for the time being you can just basically ignore that. But if we wanted to create a new one, print something, we'd have to have self in there, right? We couldn't just do, we couldn't do that. Well, yeah, we'll just say we can't do that. If we want to reference kind of stuff we can do with like the functions and the different values we have. So then if you see init or this kind of set new data, you would say, you know, this has one parameter, it takes in new data. This has one parameter, it takes in the initial data. So when I am making my node objects, I have to pass in something, as you'll see when you open up the parentheses, this initial data. And that can be anything. It can be the number 55, it can be a string 55, it can be a boolean, you know, it can be a float, it can be whatever you want it to be. See, that works. Now I can call get data, which has no, where are you at? Get data right here, which has no parameters because we don't count self, and then it gives me my data, right? So if you look at this, in the data, we pass in the string first node. It assigns it to this thing called data here, right? So now the data is going to be equal to first node. And then when I do get data, you'll see self data is referenced again here and it returns it. So when I initially make my node, I'm setting self.data to be, you know, the string first node. And now when I call get data on that, it says, hey, return self.data, which we assigned up here to be first node. Thus, I get the string back first node. So the same thing would be if I could set data, let's say 55. Now I do get data for my node. Now it's equal to 55 because, as you see here, passed in new data, which was 55, and now self.data becomes that. So basically, with these nodes, this node thing, there's two concepts to them. First, they store data of some kind of value. So that's the first thing, and that's what we've been doing. You know, when we make a node, we pass in some data, we can get the data, and we can set the data to be something else. Right? That's important. It can be whatever. We can change it from a string to an int. Doesn't matter. And that's only going to be for like this object. So I have this other node up here called node. Right? Actually, let's set the data back here to not be confusing. Right? And so this is just an instance of this class. And so this other node I made up here, which we haven't touched, should still have the data of 55. Right? It's like independent of whatever you're doing. Even though they're both, you know, initialized like this, it's just saying, hey, this is an instance of the class node, and this is a whole completely different new instance. You know, they're both of the type node, so they can both call similar things on it, but they're totally different. It's like doing x equals 5, y equals 5. You know, they're both variables that are just like a single letter, and they're both equal to 5, but they're independent of each other. So, you know, if I modify this in any way or do any kind of weird stuff to it, it's not going to affect y, right? It's like independent, even though they're both technically integers of the same value. You can think of it like that. Well, that's kind of the first big part. And if I'm just confusing you, if I'm confusing you, then I actually suggest like pausing or turning off this video and looking at these two resources first, which again, they're not that long. A lot of examples. I think they even say how like many minutes it takes. No, 3 they used to. But this is not that big. You can see a lot of examples. This one's slightly bigger. You can see by the scroll bar, but again, a lot of examples. And I think this one goes in. I would have stopped like before here. So just this kind of stuff you need. But the Medium article is really great. then come back to this video. But if you're still with me, I'm going to continue on. So the second thing that these kind of nodes are, you can think of a node like an element as well, like in an array or a list. So the kind of secondly, nodes need to know which node, if any, comes next. So you see in linked lists, they kind of go like this is a start, and then it changes on the Tom, then it changes on the Karen and Mark. So we have a value, this one's Alex, and it knows that, right? This little node, this blue box, says, hey, I have this value of Alex, which we just went through. We just assigned a node a string. We can also do an int, which is good. But the next thing it needs to know is it needs to know this arrow part. It needs to know which element or node comes next in the chain, because that's how linked lists work, right? They store a value, and then they point to a different node, which also has a value, and points to a different node, which has a value, and points to a different node. So, it's like a chain link kind of thing, one way. So if we have the data down, we need to know about what comes next. So we have n, which is our node, still set to that. And if you look here, so we've done set data, we've done get data, and we talked about this part of the init kind of method that we passed in data to right here. But you'll see there's another kind of thing called self.next, which we're setting to none. And that is equivalent to this little arrow, right? This says, hey, point to this node. So when we first make a node, we we don't pass it in what the next is, we just pass it in data. So then if we do, get next, just nothing. It doesn't return anything because we're right here. It should return self.next. Well, we haven't assigned anything to it, and it's equal to none. So then when we call it right here, we're just returning none. Might as well do that because we didn't assign anything. So how do we assign it something is through right down here, set next. Sets the next node of the given node. And again, this is confusing. I think if you do page 52 of the OLI module, it gives a pretty decent understanding of linked lists. But these are the two things they do: storing a value and pointing to the next node. So let's just restart the shell altogether. So we need to run this. There we go. So I'll have the head of our list, and it'll be equal to node. And let's have the middle. And then we'll have an end. Right. And so these get data, but then they all have no notion of what comes next. So if I have my kind of head, my starting node, I want to set that the middle node should come next. So what I would do, set next, open it up, it takes in this thing called new next, which can be anything, but we want to pass in a node to it. So then we'll do middle. But then we'll also want to do the same thing for this middle node. We'll want to set it to end. And then end is, it doesn't have anything after it, so we won't set anything to it because it's already none. So then do head, I get next, and it does return this object. So then we want to do like right. So we call get next. It just this is like the node object, so it's not like printing it out nicely or anything because it doesn't do that. But we could do something like this, which is like kind of less confusing. But this is saying, or more confusing rather, hey, get the next node. Which right here it just returns the next node, so it's returning middle. Whoa. I'll be right back. Yes, so this just returns like an instance of a node, and then we can call the kind of same properties on it, right? So I'm not going to do it, but this would basically be the same as doing that, and then we just have this new node that we can call the same kind of stuff on. But yeah, that's basically nodes, which is probably a little confusing if you haven't checked out those resources. But just know when you make a node, you can call these different things on it. And if you go to the linked list class, which is kind of similar, you'll see here, like on insert, so you can call different things on this linked list, but what we just need to do is call stuff on node. So for size and search, we'll just be interacting with the node objects. And insert kind of gives you a window into that, right? So we're making a node with whatever this data is. We're setting the next kind of node to this other node that we already have, and then we're setting the head to the new node, which the kind of videos walk through on page 52. So then we'll just need to do kind of something similar here, involving the nodes. Yeah, which, I mean, logic-wise, basically for size, you're going to want to just traverse the linked list and kind of keep count of how many nodes you encounter. So we know that like self.head is going to be a node. So then, you know, we'll have self.head, so that's node 1. And then maybe to get the next nodes, we would do like self.head, you know, get next. And then just keep doing that, you know. So get the next, add to the count, and then in, get next would give us 1. That's another 1 if it's there, if it's not none. And then keep doing that over and over, and we can kind of iterate through the entire linked list that way. And then we just keep count of that. And then same for search, very similar logic, but as we're iterating through the list, instead of just incrementing this count variable, we're going to want to be doing comparisons to the item, right? So like you can see down here, search takes in a value, so like a string or int or whatever. So maybe as we're iterating through these nodes, we're going to want to call something to get the data that the nodes have and check if that data is comparable to item. But yeah, very similar logic to this, but on the node, maybe get the data and compare it to item. And then if it matches, return true, otherwise continue until we hit the end of the list, and then return false. And again, I'll walk through those Friday. I think the instructions on this kind of comments and page 52 give enough of the logic breakdown where I don't need to do that. But I do think a big part of that is calling functions on these nodes, which hopefully the start of the video helped a little bit with. But yeah, just treat it kind of like math or random or something, basically. You know, you have this node, like, so self.head's a node. This new node is definitely a node, as you can see right here. And then you can call these functions on it, these 4. So I think I'll just leave it at that. I'll dive in deeper for sure when we go over it. But again, you're gonna need to call stuff on nodes. These are the functions, and the beginning of this video kind of overviewed the class and object stuff, but I think these resources do it better. But I think if you kind of keep them like analogous to how we have math, and we can do math, you know, floor and all that, then hopefully it's not too much of a stretch. It just is kind of, I guess, different than instead of doing import math, we make a whole class for it. But then on the upside, you know, if we wanted to add a new function to this, maybe, you know, we did like print something, right? It's pretty easy to do that. You know, like I could do print data. So then this would like print the data of the next node. So it's like pretty easy to add stuff to it that we like can't do with math, right? If you wanted math to do something different, we just can do that because there's a way technically to do it, but it's not as easy as just writing in a file like this, right? Because we're just importing it, we're just using what's already there as opposed to making our own. But hopefully it's not too bad. I mean, this whole notion of classes and objects definitely is a super challenging part in kind of framing of programming, but hopefully this gives you a little experience using it, and it's some initial exposure through these two resources I pointed to, enough where you can hopefully like get a high level overview of it, which is all that's really needed right now. But that's it. Page 52 of OLI is super helpful for these two. We'll almost certainly need to be using solve.head, which is a node. So then don't forget you can call things like that on it, which would give you, the next node. If it's there, you need to check though, right? If you do get next and it's none, you should maybe check for that. So you don't just assume it returns something and call a function on it. And then test, which should not be modified. So yeah, nothing up here should be modified at all. The node, I mean, if you really wanted to, you could, I guess, but you shouldn't have to touch anything in node, this class. Just these two functions. And then there's test down here, so you can run test. Alright, counts undefined because we have count here, we don't do anything with it. But then this is what it should print and return, these values. So when you do run it and you have code in here, you'll get the output of these 6 different functions. So then you'll get the value of 5, true, false, true, true, false. It'll pop up in the shell. And so that's the way you can test your program. If you run it and all these are true, then something's off because this should be false and this should be false. So I went ahead and threw some test cases in for you. And I think that's all I really want to talk about Lab 6 today. Most of Friday will be devoted to that. We'll walk through it, answer any questions. I think once you've taken a stab at it and kind of done the OLI module and looked at those two resources, then I think everyone will be in kind of a better position to ask questions and even kind of understand my explanations better. Because I guess if you have no prior knowledge at all of these classes and objects, it's probably a bit confusing what I was talking about. And yes, I think I'll leave that for Lab 6. Again, definitely check these out. Page 52, I think I even say that in the instructions. Yeah. It's due Friday as well. Don't forget you have an extra day on it. It's me trying to make a comparison to math and random. Then basically just describing the two functions you are to complete. And yeah, that's what the sample output should look like when you call test. And then not too much to talk about for homework 6. It's like a guess the word kind of game. I'll definitely talk about it more though Friday and of course Sunday. But I think this screenshot should kind of help you with how it should look like. The starter code is very slim, which is intentional, and there's also this kind of Word file to download that we'll use. So for like the game of like guess the word or hangman as it's sometimes called, there's this get word function, and so this randomly selects a word from this large text file of words. So it reads in this word file, and it kind of loops through it. And this highlighting is terrible. So this is basically saying, hey, treat this text file as all words, and then we need to read it in. So basically convert what's in this file to like a large string, and then split, so it splits them based on new line. So then now we have word list is this huge list where each element in the list is a word that's contained in this text file. Which, yeah, so it looks like that. And then random.choice just randomly picks one of the elements from that list and assigns it to word and returns it. So this will be the word we're trying to guess. So you should call that. But then the rest of the kind of game logic is up to you. But I mean, it should follow the standard rules, and I kind of have some in place here to try to help clarify anything. You know, you start with 6 lives. Every time you incorrectly guess a letter, reduce the life buzz by 1. If you have 0 lives, the game's over. Only deduct a life if they guess incorrectly. You know, in Hangman, if you guess like the letter K and a K hasn't been taken, but it's not the word, you would lose a life. But if I guess like L, and I've already guessed L before, then you wouldn't lose a life on that. You would just get asked to, hey, guess a different letter. You know, only if the letter's been guessed for the first time and it's not there would you reduce a life. Same thing I said for this, you could assume there's always going to be letter inputs, like L or O or whatever. But also sometimes maybe someone will put in like LO, for which you need to say like, hey, only single letters please, try again. So you're going to have to continually prompt for the input of the user like we did for tic-tac-toe. So you may want to just kind of copy that little bit of code and change it a little bit. Lowercase letters, so a capital A and a lowercase a should be treated as the same. So if you've already guessed lowercase a and it was not there, then if the user tries capital A, you should say, hey, you've already guessed that letter, try again. When you guess a letter, you should add it to this list of already guessed letters, and it should be alphabetized. This way it's kind of easy to parse, and you can tell if you're like halfway through the game, like, oh, did I guess the letter D yet? You can look at the list and say, no, I didn't, so then you can guess it. Then between each prompt for the please enter a letter, print the lives, the currently guessed letters, and the kind of state of the game. So kind of the basic stuff. Then the game's over if the letters all get guessed. So you guess the word, or if you're out of lives. So I think fairly standard stuff. I think the screenshot does a nice summary of it, but also there's these kind of 5 bullet point things. But again, and at the very end, here's some kind of logic breakdown of it. So I won't really go over that now. But you can divide it up in any way. I just don't want to see all the code in start. Right, so I'm going to call start to get the game running. So please don't modify that. I think I even say that here. Kind of messes with the grading workflow if you change start to be like play the game or whatever. So keep that the same, just call the logic from here. But the rest, you can make however many functions you want. Ideally, just don't make one big function that has the game kind of divided up into helper functions. That's kind of part of this. Just it's up to you to get the logic. So less scaffolding than the tic-tac-toe one. But we'll dive into this deeper later in the week. But if there's no questions, I think I'll sign off like 15 minutes early. Grades for the quizzes are out. I'm currently grading labs and homework still. If you go into Canvas and you have a comment on one of those in the past 2 weeks, some people emailed me submissions because they use like flex days, and so they're not on Canvas. So if I leave you a comment that says like, hey, where's your submission, or did you email me this, I won't be checking my email, but like maybe email me again or post on Piazza like, hey, you left me a comment on my Lab 5 about where's the submission, and I emailed you it when I said I was using the flex days, and I'd be like, oh, okay, thank you. So I guess keep an eye out for that, but the quizzes should be out. the 4 and 5, or 3 and 4. But that's it. I'll be on Friday to go over the lab, dive back into these kind of resources and objects and classes a bit more, answering any questions about them. And again, I just know that these are kind of new concepts, but I want everyone to try at it. If you don't get it exactly right, that's fine. That's what labs are kind of for. That's why we walk through them. But I do want to see some attempts at it, right? I don't want a submission that's like, I can't figure this out. Like, no, you will not get credit if you just leave a comment. Like, I want to see some code you were at least trying. Whatever. I want you to try to call get next on stuff or make comparisons or something that show you actually tried it. But hopefully it won't be too bad if you just, use these functions on the nodes and then maybe do a loop and a conditional. But nevertheless, we'll walk through it Friday. And I hope everyone has a good week. And I will talk to you all again then.